Okay, hi everybody. Welcome to the last session of CoqPL. This is one of the fun sessions. Yves is going to tell us about some news on Coq development, and then we'll have an open session with several Coq developers. I think Maxime, Enrico, Yves, and Jason. And you'll be free to ask questions at that point. So go ahead, Yves.
So I have to be a bit anticlimactic here because we prepared that at the last minute, so I don't have much to say, in fact. But, what is happening here? Oh, this is stuck. So, okay. So the one thing that happened over the last year is that we've had 2 releases. And 2 releases in 2022, and Coq 8.16 was the last one in September. And one thing that you have to be aware now is that the release of Coq is only the first step in a longer process. The real availability is when the following release of the Coq platform happens, where you are going to be guaranteed that all the libraries that are provided in the Coq platform are stable. You should basically now consider that what you are accustomed to see as guaranteed stuff provided with Coq is what is provided with the Coq platform. We make a lot of effort to make sure that everything works well together in each version. And for us as a core developer team, it's really important because it also means that some of the work of preparing the release is now shared with the wider community, in particular Michael Spectrum. So as you see, the Coq 8.16 was released on the 5th of September. We needed to produce another revision in November. And the Coq platform release that corresponds to that period was actually released on October 10, so slightly later. But with that version, you have everything that you want to use. So it contains all the libraries that I'm accustomed to use, like Interval or Mascomp or Iris. I think there's also a version of Concert. So this is what we really try to make sure that we cover most of the important usages. So we're going to release the Coq 8.17 in a few days. I think the release candidate, RC1 is for release candidate, was already released. So people have already started to prepare versions of their libraries that are compatible with it. And the Coq platform, the corresponding Coq platform release should happen in about a month or 2. So this is really an important decision of the development team, is that we really want to have time-based releases now, and we managed to stick to this discipline over the last year. Okay, so if we want to look at what was done, well, one of the counter aspects of having this time-based release, it means that we do not necessarily have big announcements to make for each release. So at some point, I'm a bit off guard because I don't know exactly how to explain what is new or in a new release. But it also, you have to understand that there are a lot of bug fixes that go through. So one in 8.16, what was done is there was an improvement in the guard condition for structural recursion. This is related to work that was actually formalized using MetaCoq. So now there's an ensured property about the code that is developed. I think every function is now guaranteed to have a strong normalization. And there's an associated proof done using MetaCoq, which is a big novelty, in fact. Even if for the user experience, it may be a very small change. So there's been work on the SPROP side of things. You know, SPROP makes it possible to be very precise about proof irrelevance. So when there are proof irrelevance objects, they are replaced by tokens. That makes that the conversion has been changed in such a way that whatever reduction that needed to be done before on these paths is not done anymore, and so we gain. And there is work on a new addition to the notions of coercions and the possibility to have non-uniform coercions. I'm not going to go too much into details on this point because Enrico is present and he was a very active proponent on this topic. So for 8.17, which is going to happen, as I said, in a few days, we have a lot of work that's been done on improving LTAC2. So there is a very big push from the development team now to make sure that LTAC2 is going to grow into the place that was occupied by LTAC. And it's not finished, but the push is already visible in that release. And the other things that I saw in the changelog, but I don't understand all of them very well, so is that there was an inconsistency in VM compute that was difficult to trigger, but people found it when looking at the code, and so this has been fixed. If you want details, I may be able to give some, but only in private, because what I say on the topic may be completely wrong. And there is also something that is very useful at the level of user experience, is the possibility to enable or disable notations at an individual level. And another thing that is really a change that is important for the developers is that you may all know that a new version of OCaml is coming. This new version has bumped the number of the main number to 5, and this is because the new version of OCaml has support for multi-core programming, concurrent programming. So we, as Coq developers, made sure that the code of Coq is going to be compatible with OCaml 5. We don't push you to use OCaml 5 because there's no guarantee of a gain in performance right now. I think it goes backwards for us, but we'll see in the long run. And so this is basically all I have to say about this. I talked about the Coq platform. For me, it's a really important effort to support. So this is something that as users, as teachers, you should really benefit from it, because there's a big effort on the Coq platform to make sure it's going to be usable easily by students or by newcomers, with an easy way to have packages that are installable on a variety of platforms. And so, as I said, the Coq platform releases follow the Coq releases. The software, the libraries that are on the Coq platform are there because there is a gentleman's agreement between the library developers and the Coq platform maintainer that all efforts are going to be made to make sure that these libraries follow the release of Coq fast enough. And Michael Soktrop, who is the main actor on this topic, also asked to have some help on selecting the libraries that are going to be on this platform. And for this, we started to constitute an editorial board. And because we're here at a workshop associated to CoqPL', I would like to say that, in my opinion, it would be nice to add one person who would be more specifically interested in the application of Coq to programming language in general. So Benjamin, or I'm opening the question. If you know somebody who could do that, then this is about it. So what do I have more than that? I'm at my last slide. I had prepared some written document about where we are going to work now, but in fact, I'm not completely comfortable with giving written information on this because, as I said, this was prepared at the last minute, and I'm not completely sure that my opinion about where the effort is going is representative of what the other developers are thinking about doing in the future. But frankly, my opinion is that there will be a lot of effort on continuing this LTAC2 progress to make sure that this set of tactic and way of programming the tactics is going to grow to be the one that is preferred. And in the same vein, there's also a big push on making sure that we streamline the user interface front. We want to put a lot of effort on making sure that VS Code becomes completely usable. Well, it's already usable by a lot of people. People are mostly happy with it. We want to make the necessary effort to make it really sturdy and a good productivity tool for everybody. And when we are sure about that, we probably are going to phase out efforts on other user interfaces, especially CoqIDE. So this is my opinion about what I think is the current roadmap. So now I'm finished. So I suppose you get the floor and you ask whatever question you want to ask. No, I don't have to.
So I think we'll take a second to unmic Yves, and then we'll switch to the mic.
How many microphones do you have?
One microphone.
Okay, so just let this one go around.
This question is a little funny with Jason being labeled as part of the Coq team for this panel, but certainly our team at MIT has come to believe there are really serious performance bottlenecks in the proof engine of Coq, and that never gets mentioned as a top priority, but it seems to totally block industrial adoption. I wonder what folks are thinking about that lately, and Jason could say more in a kind of weird two-hat talking to himself way to explain this if you wanted.
My sense of the issue is that the only okay. My sense of the issue here is that the only person working on Coq performance is Pierre Marie, and he's pretty good at it, but he's only one person. So my sense is that there's like a lack of engineers working on it problem. And as far as how to fix this,
So there is a background problem that we don't have enough manpower as Coq developers. So I'm also doing a lot of effort myself on trying to muster more funding from the INRIA institution to make sure that somebody like Pierre-Marie can concentrate on the problems that he has to concentrate on and not be too distracted by other kind of issues. So I hope this is going to help the answer of Jason.
I don't have more to
Hello, I'm Enrico Tassi, and I worked on many parts of the system, from SS Reflect to the type inference part of the elaborator of the system, the math comp libraries. And now I spend most of my time doing this extension language called CoqLP. And
Hi, I'm Maxime Dénès. So I'm an engineer working on Coq. I think I've touched almost any part of Coq so far in terms of refactoring, improving the behavior in some ways, or even the logical consistency sometimes. And these days I'm involved mostly on working on user interfaces, especially VS Coq. Both like maintaining the current version of VS Coq and also working on a major new version, like written from scratch with other engineers. And I'm involved also in the Coq consortium with Yves.
So, other questions? Talia.
Wait, does this work? Or okay, cool. Okay.
I'm Jason. I don't actually spend most of my time working on Coq proper, so I'm sort of in a weird position here relative to the other Coq core team members. But insofar as the Coq system, I've probably mostly reported bugs. and I'm the expert second to Pierre Marie on performance of the Coq system, I think.
Jason is being modest. He has reported a lot of bugs.
Cool. Yeah. I actually wanted to dive a little bit deeper into the performance stuff. I'm curious what parts of performance and what parts of performance are causing the bottlenecks from your perspective, and like what parts you would work on if you had the the people, the resources to do it. And yeah, I mean, because so from my perspective, like we sometimes have terms that we actually want to compute something, and we don't want to completely erase the proofs and so on. And reduction, and especially when so normalization, and especially when we've used any kind of heavy automation that ends up producing really large terms, is sometimes completely intractable. But then we end up doing like proof term optimizations, and we get the performance down to like 10% of what we had before. And I don't know if people are facing different performance issues from each other, or if it's like kind of one more, or if they're really common, like if that's a kind of issue that you faced with your style of proof and so on. Yeah.
How much should I say on this? I feel like I have an hour's worth of material on this. Okay, but the like brief version, I think there's performance issues in doing proofs interactively. There's performance issues in running proof automation to build proofs. And then there's performance issues in QED and like checking your completed proof terms. And I think almost all performance issues fall into one of these categories. My sense is that the working in reverse, I would class that under mostly the QED. Like once you have a term, type checking it. Yeah. So I think in the last one, that's the one where I know least about the performance bottlenecks. I know that universes are a bottleneck for some people. And I think another big bottleneck here is that when your proof building takes a different reduction path than the kernel, like if you use simple CBN, something like that, you're very sad at QED time because there's no way to annotate the term to be like, here's exactly the reduction path to follow. I think finding a way to like have the kernel follow the same path that the proof building does would help with this. As far as doing, the one that I know the most about is bottlenecks in proof automation, and I think so I think there's sort of a research question for the community here, which is that as far as I know, no one has spec'd out what it means to have an adequately scalable proof engine. What I mean by that is something where you can do proofs in a modular fashion, where you can write some automation for one bit and some automation for another bit and hook them together. and laying out like what primitives do you need to handle everything in this modular fashion in a way where you get error messages at the location of error, not like, oh, I'm just going to build a proof term and hope that it checks once I assemble it. And I want to see like what does it mean to have an adequate proof engine that like lets you do everything at scale? What are the what performance do you need from the primitives to get a proof engine that looks like this? And then there's also the question of like implementing a proof engine that lets you scale like this. And I think empirically in the Coq system, currently there's a bunch of issues with EVARs and with large context sizes, and also with duplication of terms, where if you're building a term, oftentimes you'll replicate things that you don't want to replicate. So I guess to sum up a little bit, there's like controlling reduction, controlling conversion, controlling where and when type checking happens, and then how even like what primitives you need to do this all modularly in a composable and scalable way. Do any of you want to add to that?
Yeah, so to still go on about this performance point, so when both when you do proofs that are heavy on type classes and also for the kind of proofs we have in Iris, where we do proofs embedded in a logic, we get a lot of like duplication of subterms, like a ton of that. And from what I understand, there are some pretty neat things you can do here. So at least the lean devs claim that that's the case. I don't have the, I don't know how to completely validate that. But basically, if you, Coq does hash consing to not actually have exponential large memory consumption for all these shared terms. But that doesn't help when you have all sorts of things that traverse those terms as trees in unification or reduction or whatever. And from what I understand, I don't know if lean achieves this everywhere, but there is some chance here for exponential speed up if you can actually exploit that sharing and don't have to retype check the same thing every time the same subtree appears in a large term. Is there any hope of getting that in Coq? Is that even possible? Is that already done in some cases? Like, what's the status of that?
I'm not an expert on this. The one thing that I do know that's an unsolved problem here is how you get hash consing that you can persist to disk in diamond dependency problems. Like the hash consing relies on whatever terms you're hash consing being globally unique, and if you have two different files that construct the same term and then hash cons it, and they get like different unique identifiers, and then you try to load both those files. Now, whenever you load the file, you need to do something to deduplicate that. And Coq does some amount of hash consing and sharing. It doesn't achieve maximal hash consing for this reason, I believe. And what else do I know about this? Right. Yeah, I think there are also performance considerations on the other side that I think Georges Gontier told me about, that sometimes I think lazy reduction will share its unfolding across similar subterms, and sometimes this is not what you want when you're doing canonical structures, where like there's one place where you need to know what the projection from your record is, but if when you unfold it in that place, you unfold it everywhere, it ends up costing you a lot more. So this is a sort of dismal, like, it's not entirely clear what the optimal point is. So for sure, we can't just like go copy the like known optimal point. But again, I'm not an expert on this, so it could be that like Lean knows how to do the right thing, and we should just copy them. I don't have a more solid answer than that.
So I'm really looking forward to see exactly what they do in Lean. But a long time ago, when I got my position at Iria, I got a permanent position. So I said, now I tackle something really hard. Took me 6 months and I failed. And that I tried to implement a conversion strategy based on congruence closure, union find, and stuff like that. And for this, I had to maximally hash cons everything, okay? I was doing it on the fly, so the cost was really high. Okay, and the benefits were visible, especially in the worst cases, but the cost of hash consing was considerable because most you at least I'm talking about conversion, okay, not the more general proof engine where you use terms with holes. Okay, I was talking about ground terms. But there, 99.999% of the times, you are solving trivial problems. Okay, so the overhead of maximally sharing is more expensive than what you gain in these simple cases. So I don't know, but the sentence hash consing will solve all your problems is a bit. I don't believe it like that. Yeah. So in Coq, we don't unshare terms because we like it. So there are many functions that try to be smart, and if they traverse the term and don't change it, they won't duplicate it or stuff like that. So sometimes maybe some piece of code is stupid and does it, but in general, we try to preserve the sharing we have. So it's not that we don't try to compress, but we don't even lose compression for nothing. So.
And many functions do have a fast path for physical equality.
Yes, yes. So opportunistically, we test for physical equality, but given that it's not everything is not hash cons, we cannot say, oh, given that pointer equality set false, it's false. So we are in. But let's say I just wanted to say that it's not trivial. It's not just hash cons and you will win. I wasted 6 months.
Hi. So my question will be more on the user interface side. So maybe Maxime, you can answer me. I wonder if there is any plan to expose some API to get access to the concrete syntax tree of pretty printed expression. Yeah.
So access to the concrete, pretty printed expressions.
Okay, so I'm no expert, but from what I've seen when trying to build my interface, I can only get access either to the abstract syntax tree, like the kernel terms, or to the concrete string representation.
Yeah, so that's a very good point. So indeed, that's a problem most user interface implementers face currently. And there are plans, so we have been having discussions, including during POPL about this. So there are plans to make it possible. So just not just a matter of exposing, but we want to improve a bit the kind of output that you can get from Coq. So like being able to have Coq output terms with rich annotations. So for example, you want to know, so this is a term, that particular part is a notation, and so on. Okay, so maybe also typing information. You could imagine a lot of things. But today, it's true that today either you have like the full-blown AST of Coq, or just like a list of characters. It would be nice to have something more structured. And I think there is a general consensus that this could make possible for user interfaces to explore new areas in terms of design, like exploration of goals and subterms of goals, reusing part of this feedback with the rich annotations for further queries to the system. And so a lot of interesting things. So I'm expecting that we make progress on this issue like in the next couple of months or so. Yeah, I think it is. At least to do better than what we have today. Sure.
Just to add to that, we are a few people who've sort of been having meetings during POPL about the UI issue, and it sort of seems like it's finally taking off a bit. with the LSP server for Coq and all of this, right? So we're hopeful that it will be better, and anyone who wants to get involved, just please get in touch, right? So yeah, so no, but it's an excellent point. Yeah, I don't know. Yeah.
Thanks. Hi. Maybe after performance, I want to talk about the second most annoying topic, which is maybe you can guess universes in particular. Like I've been lately trying to combine like multiple bigger Coq projects, like for example, like Iris and like interaction trees. And if you do then a bit more complex stuff, you easily run into very weird errors, which are very hard to debug from some like universe constraints, which were, I don't know, coming from some some weird places. Are there plans or in general ideas how to improve the situation with regard to universes in Coq?
So I think I'm going to sell one of my projects here. If you run into this, you can use the bug minimizer that I wrote to try to get a small test case that sees where your universes are going wrong. I assume you're referring to like you try to import two files and you get universe inconsistency, can't enforce some universe less than some other universe because universe equation. Yeah, I don't have anything better to say than like minimize the test case to automatically and then try to understand like what's actually generating the constraints.
So I'm also not an expert on the topic, but what I can say is that the state of universes today in Coq is fairly complex. Like we're having at the same time universe polymorphism and also like older mechanisms like template polymorphism and so on. So this makes both the theoretical landscape but also the implementation landscape a bit difficult. So working on things like improving error messages or like guiding the user, exposing nicer syntax is fairly difficult with this combination of features. And so from what I understand, there are efforts by, I think, by Pierre-Marie, Pedro, by Mathieu Sozo, on having a more uniform way of presenting universes that would subsume both of these mechanisms. And my hope is that once we have this nicer foundation and nicer base implementation, it should be easier to address the user needs in terms of engineering around it and tooling. At least I hope so.
Yeah, I mean, I guess you have answered this, but anyway, I mean, this might be naive, but it seems the fundamental problem is that we have these global universes, which then get pinned accidentally somewhere and then get pinned somewhere else in some other dependency, and then 5 layers deeper, something doesn't work. So it's not a user interface issue in that sense, right? Like the ideal world, I'm not sure if that's realistic, but in the ideal world, there just would be no global universes, and everything just gets instantiated in every use. I'm saying just with a lot of quotes here, which, if I understand correctly, would amount to not having template polymorphism and having proper universe polymorphism everywhere, which I thought was like a long-term goal. I don't know if that's like, I don't know what happens currently if you make the list type in the standard library universe polymorphic, but is that still the plan, or do we need this new theory because it doesn't work, or like, yeah.
So there's two reasons you'd want global universes. One of them is performance, that if you have sort of local universes everywhere, you get a lot more constraints and your performance can blow up. The other issue, the reason we can't get rid of template polymorphism yet is because template polymorphism lets you instantiate things with prop in an impredicative way. And universe polymorphism currently does not handle instantiation with impredicative prop. Pierre-Marie is currently working on sort polymorphism so that you can write your definitions polymorphic over prop or sprop or anything in the type hierarchy. And I think once this is merged and implemented, and then once you can do these like sort polymorphic in addition to universe polymorphic definitions, then we can drop template polymorphism. And backwards compatibility is always going like always an engineering struggle, but then you can hopefully get rid of template polymorphism, make everything universe polymorphic. Hopefully things will work.
So you just gave two different answers for why not to use universe polymorphism everywhere. I just want to use this to connect to another common theme that I feel like doesn't get enough love in the Coq development process, which is trying to minimize the trusted base of proof checking. I think that's another reason to even prefer a world where there is no universe polymorphism in Coq. I'd also like to see features like desugaring the module system into a core language and doing whatever we can do to minimize the complexity of a reliable proof checker. Any rumblings in that direction lately in the Coq development world?
My first thought there is meta Coq for Coq and Coq, and if you route everything through meta Coq, that's a much smaller trusted code base potentially. That's a different sort of answer than I think what you're looking for.
Also, it's not clear to me that it's harder to account for universe polymorphism in, say, MetaCoq than the current things we have, like template polymorphism and so on. So actually, yeah, that's my point. So I don't think we're adding to the TCB in this sense. So switching to universe polymorphism is also a way to, and removing template polymorphism is also a way to reduce the.
I mean, you can do the same thing with universe polymorphism. I think there's a guarantee that there will exist some finite number of universes that you can concretely instantiate whatever set of polymorphic universes you have. And so in theory, you could just elaborate to that. I think as far as the modules go, CoqCheck doesn't check functors, only checks instantiated modules. So I'm not sure how much that impacts the TCB if you consider CoqCheck rather than CoqC.
Sorry, but maybe it will be a bit provocative, but is it a real problem that the TCB is not so small? I mean, there are some bugs we find, we fix them, okay. But I mean, is there a real application Coq cannot reach because of the TCB not being as small as HUL-Lite? Or sometimes I like all the features that are in the logic of Coq. So, and modules, I mean, I don't like them, okay? But they are the only way we have today to seal stuff behind an interface. So I wouldn't desugar them, at least not yet. But I will be all ears if it's limiting you, if people in the industry says it's too large.
Since modules have been mentioned, I would love to hear the views of the developers on the state of the library ecosystem, and I mean both sociologically, but also choosing between type classes and modules and canonical structures and something else, or kind of healing those inconsistencies.
I'll take the hot potato. I think that the library ecosystem is one of the assets of the Coq system because there's such a long history of developments. And right now, it's an asset that is actually playing against us instead of being really used as an advantage in perception, because people get lost in it. So streamlining should be done. I would like it to be put on a roadmap of work for the evolution of the whole Coq community. But the Coq developers themselves, they don't work on the library. That's not. There are very few to work on these. STDPP is not developed by the Coq developers, and so I think we have to collectively understand how to make this work. That we are going to streamline this ecosystem. I think us as Coq developers, we have to provide a good environment for this, but it's too much for the Coq developers. And so one of the efforts I'm trying to make is to make sure, this is not another announcement I wanted to make. We are going to hire people to help on these topics. So if you are interested in participating in this kind of effort, then you can contact me and Maxime, and we're going to see what kind of positions can be arranged. And so when I say hire, to have something on a permanent, somebody working on a permanent basis on this kind of project. But we are not going to hire only for the Coq development itself, but I think we could also put some manpower around this specific effort of streamlining the library ecosystem. And so that's part of the answer. Maybe you have something to add?
Yeah, I think the situation on libraries is really something critical that we should address. It's at the same time an opportunity, and at the same time kind of danger for the ecosystem, I think. So it's true that we Coq developers typically do not develop ourselves large-scale libraries, but the choices we make in the language has a lot of impact on what can be done in the libraries. And something that maybe sometimes we underestimate is, so since Coq is a research object, we tend to have to explore features of the language and maybe sometimes even integrate features that are partially redundant, which if you stop at the limit of the Coq system, it's nice because it just gives more flexibility to users, right? But then when it comes to library, it also has sometimes the drawback of fragmenting the ecosystem. By fragmentation, I mean like if one library is very nice for some applications but uses type classes, and the other one is very nice for other applications but uses canonical structures, and you need actually to use both, you will have interoperability issues. So this is something that is complex. I think we're not the only ecosystem to have this kind of problems. I like to think of the Haskell ecosystem, for example, having the same kind of problems in some areas. So what, I mean, I don't think there are easy solutions to this complex problem, but one thing we should do probably is to be a bit on the Coq development side, is to be a bit more explicit. Like when we add features that could be redundant with existing ones. So first, we should be maybe more explicit about like they are experimental or not, or that's the new recommended way of doing things. But also we should have so these like cycles between adding new features for exploration and then consolidating and validating like one recommended way of doing things for library developers. And I think we are lacking a bit of maybe communication around this, especially for type classes and canonical structures. Now, sometimes it's not just communication, it's that we don't know also what's the right way of doing things. So I know there is work around trying to unify approaches to type classes and canonical structures. But to my ears, there's always the danger, like I'm promised that there is a third way of doing things that is going to subsume the two existing ones. Once we merge the third one, I hope we don't get three problems to solve at the end. But maybe you want to mention what I'm referring to?
Not really. Yeah, that's my research, and it's secret. No, maybe, but that's still research. So I just wanted to mention that maybe there are many libraries. I see two decent replacement for a standard library. One is MathComp, the lower layers, not when you do abstract algebra that I don't understand, but when you are like discrete tiny stuff, and STDPP. Maybe if I'm wrong, if I'm ignorant about something, raise your hand. Maybe Robert will come to Nice soon, where other MathComp developers are, to try to at least get the lower layer in common or similar or linked in a way. It will be a start, but again, I think Maxime's point was fair. we are the Coq developers. We can help to catalyze things to make it happen, but we are not the developers of the library. We are kind of the maintainers of what we call the standard library that nobody really likes completely, but the libraries which are nice and are different are out there, and so we can help, but most of the effort should be.
Yes.
Yeah.
I think speaking to that last bit a little bit, and this is just my own perception, not the perception of the whole team, but my sense is that no one feels ownership over like the library system or the even the standard library. My sense is that there's no one who like feels ownership over what gets in the standard library and what doesn't. And so you end up in this awkward situation where like no one has the time to devote to like carefully curate things into the standard library, and also no one is strongly blocking it. And so you get these pull requests that sometimes get in by accident and sometimes just languish for no particularly good reason. And I think the core problem here is, and maybe this is changing with the Coq platform team, but it seems like the thing that's needed here is someone or some group of people who feel ownership over curating the Coq ecosystem and being like, this is the suggested thing to use for this approach, and like deciding what things get into the standard library, what things should be in the platform, what things are just on OPAM, and sort of organizing all of this. And maybe part of this is a lack of manpower in addition to the lack of like designated ownership.
I would like to take this opportunity to say good things about one of our colleagues. Theo Zimmerman did a lot of work on making sure the developer team for the core system was working well together. He provided tools at the level of GitHub and all that. And but his research is mostly on understanding how these open source developments work together. What is where does the social pool come from? How can we encourage it and things like that? So Theo just got a permanent position as a professor in Paris, and we're also in discussion with him to see how we can now empower him even more to do this kind of animation. And maybe we are going to push the animation towards this direction of libraries. So that's among the things that I would like to say, that there is positive movement actually. Even we have the one thing I can really guarantee you is that we identified the problem. We know we want to find a way to make this progress, but right now it's only a big will to find a way, but we haven't found.
So I have a kind of maybe higher level like community question. I think it would also help you get more contributors for a lot of these things. So okay, when I was in grad school, being a kind of a core like part of the community was the most useful thing in the world for me. Like I would go to friends for the Coq users and developers workshop. I'd get more done in a week than I did in months. And it would give me new ideas, and it was wonderful. Now I have a team full of students who kind of like 5 grad students who recently have been going through this pandemic thing, are not really as connected to the community, are a lot more shy than I am, don't feel comfortable like asking questions in the Zulip, don't really know the core community. And not only do they need help, like they need help porting things to newer versions, they can get it in the platform and stuff like that. They also want to help a lot. Like they're really interested in like optimizing reduction and these sorts of problems that people bring up. So I'm just wondering like how we can bring them and also like other people in similar positions. I assume there are a lot right now who really want to be a part of the community and get them more involved.
So before the pandemic, we organized, well, I don't see you, but we organized a few times in Nice or in Nantes, I think, workshops where users and the core devs meet. And we were discussing about organizing it again this summer. What? Would you send your students? Or no, people would be interested in a week with us, hands on your code, and we are in the room. You can ask whatever you want. So that's the first thing that comes to mind. And hopefully the COVID situation will allow us to do that.
Yeah, maybe a related thing. So I think you mentioned that some of your students could be interested in topics like improving reduction and so on. So for this, I think we are also lacking a bit of material, like past experiments, failed and or not, and maybe like again a roadmap with priorities and things we really want to look at first. So that maybe that's something we could do as a preparation for this kind of events.
I really like the question. I don't have a good answer to it, but if you have suggestions of things you want to see, I think that's also valuable. What?
Okay. Yeah, I mean, I think it is a hard question. The users and developers workshop, I do think, was one of the best things for me ever, and it's interesting because like the online approach to this, I do think is useful for reaching people who can't go in person. But not having it in person, I think none. I even couldn't get myself to go just because of the timing and being able to unable to detach from things that were local. And so I think maybe, yeah, at least having some of them in person or something like that would be amazing. And I would send my students in a heartbeat. Um, in person or um, like maybe at least once every 2 years or so. I don't know. Once you know the community, you know the community, but it's terrifying at first, and especially for people who are like more shy than I am. I don't know. I talk a lot. Um, yeah. And then I think maybe ways of signaling just being more open to questions and helping. I think people don't, once you know that you can just kind of show up in the Zulip and like poke people and that's okay, it's like not that scary, but I think it's really scary for people to do that the first time. I actually don't even know like which forums are the ones people use the most right now because they've been hopping around. But Zulip is what I suggest to students. And I think just even having like uh, I don't even know, like a little, do you have office hours or anything like that? Uh, sorry, did you?
Are you finished?
I mean, office hours are another one that I would think of if there is one. I don't know if you guys have one like that. Like,
So it might be also, I've been in that situation myself where I actually mentor people into going to Zulip. So you may want, you're a lot of Coq experts in using the Coq system here, and you could actually volunteer answers to people and sometimes say, oh, but I think you've come to an interesting point. Why don't you submit a question to Zulip? And you know, this is something that can also be done. But Vadim wanted to.
I have a next question, unless we're still on this topic. We're moving on, or okay. I have a next question. I have a question about the extraction. So what's happening in the extraction world? There was some talk about some certified extraction, maybe happening through the MetaCoq way. I don't know what's the story there. Because I think as we look at the Coq as ecosystem and we'd say, okay, you can write this and verify some code, and then you can extract and suddenly have magically certified implementation. But there's a huge gap there because whole extraction is not proven, not certified. And are we planning to address that in any way?
I don't have super fresh news, but the people working on it are in Nantes. I know for a fact that they just hired a very smart postdoc working exactly on that topic. So I think progress will be made, but there, and I don't think we. Do you know?
Yeah, I think Metacoq has a paper on certified extraction that is
Yeah.
listed on the Metacoq homepage. I don't know what it claims to accomplish, but I think it exists.
But still not complete. Some optimizations are not there, so this is what the postdoc will iron out, hopefully. Yes, and he hired Katsuhiko Sakaguchi to work on it. So if you want more news, maybe you should write on Zulip.
So this is a topic that was dormant for quite a few years, and the answer is it's actually active now. So I don't know when you will have a definitive. I'm sorry, I just pressed the button, but it is active now.
Okay, we're at about 5 p.m. So Yves told me if we run out of energy or we hit 5 p.m., we're going to stop, and it's 5 p.m. So let's give a round of applause.